Hey, hi friends. Good evening, everyone. Welcome to day four, sorry. And we are talking about agricultural analytics. And as part of the agri analytics or precision-based farming or farming analytics, or you can talk about AI-based farming. Right? So different fancy words we can use um, in the um, understanding perspective. We are basically talking about applying analytics concepts on the agricultural sector. As a business, agriculture is generating a lot of data. And using this data, we are trying to uncover a lot of hidden facts, hidden patterns. And from the knowledge of these hidden patterns and hidden truths or hidden facts, we will be able to take an appropriate decision to ensure that agri as a business is excelling. That means, in short, we are trying to ensure that the farmers who are the uh, main stakeholders here, who are getting the benefit, uh, are eventually be given more profits. Right? The primary objective or the underlying objective here is to ensure that the farmers of this country are taking the benefit of analytics. The output of any farming has to be improved. In short, we are trying to optimize the process of farming. And in turn, this will help the farmers to get better returns. Now, from this perspective, I've also talked about the concepts of data analytics or data science, to be precise. And under the data science, we are trying to analyze the data that is getting generated and try to map it to the various facts of the business. And of course, we're also trying to identify certain answers with respect to the business challenges that we are facing. Now, in previous class, I've also explained what is exactly data mining. Data mining is a process of extracting meaningful information from the data that we are receiving from the day-to-day activities that your agri department is generating or agri sector is generating. So it's a quantified, or you can say mathematical or statistical based techniques which are being implemented onto the data using certain techniques and trying to extract that pattern out of the data, try to understand questions, right? And try to understand the answers for those questions. Now, this data mining as a process is broadly, again, further segregated into two types or two approaches. One is called as unsupervised. The other one is called as supervised. Right? Unsupervised learning and supervised learning. So if you talk about your, let's say, cattle, if I have to explain in the same terminologies that the business folk understand here, let us assume that we have a cattle. Okay, let's say cows. The cows and buffaloes, let's say, are basically right, left for grazing. They go for feeding. Let us assume that we have a area and we are leaving the cattle without having any monitoring. Right? We don't have anyone keeping an eye on the cattle. The cattle, the cows and buffaloes basically right, munch on these grass, lush green grass, they feed, and eventually they return. Without having any monitoring, the cattle will do its job without any supervision. Right? So this is called as unsupervised learning. In place of cattle, I'm talking about a machine. right? This machine is basically taking the data and trying to understand what it has to do, what information we can have from this particular data. In short, we are trying to identify pattern. Now, on the similar lines, we talk about supervised learning. So imagine the same cattle is being managed by the holders, right? The people who manage these cattle. They control it. Basically, they are ensuring that the cattle goes in a specific order. So it is being done by the controllers. So it follows a specific instructions. It follows like this. The cattle follows the instructions of the handler, and then they return. Right. So here the cattle is feeding under the supervision of the handler. Right. So if I have to put this concept with respect to data mining concepts here, from a data perspective, if this is my data set, I have many fields that we are capturing. Like yesterday, I have shown you a small snapshot of the data. We will be working on the same data set now. It's talking about various details of crop, the season, location, the area of the agricultural land, the humidity, the land, the soil properties, the humidity properties, right? The production, etc. Some of these fields that are there recorded in the data set. So these are various values that we see in the data set. Now, what we're saying is, hey, all these fields together, if I want to analyze, then there might be some hidden facts. Now, what are those hidden facts? Nobody knows, right? So there's no one to guide or nothing to take a guidance from. This is basically called as unsupervised approach when we're trying to identify the pattern from this kind of a data. Now, imagine the same data set will also have additional field, one additional field, which we call as Y. Assume all these are multiple input factors and we have one output. Probably it talks about the yield, right? The production output. Let me say production. So if I have a production, the outcome, given these facts, right, given these various characteristics, I already know what kind of returns we will get. What is the production of that particular farm or that particular crop? So here we are trying to identify the pattern in the data with the guidance under the supervision of the production variable, a production column. So this is the difference, supervised and unsupervised. In short, Y is not there, Y is there. Okay, it all depends on the Y variable. We also call it as label data. All right, now, as part of our journey today in agricultural analytics, I'm going to try and explain how we can actually take a benefit of one of these techniques, which is from unsupervised learning. We call this particular technique as clustering or grouping. So if you have a large amount of cattle, assume you have cows, buffaloes, goats, sheep, right, hens. So this way you have different types of cattle all mixed together at a single place. Everything is mixed like this. Now, in order to manage the cattle, it would be obviously better if you can segregate them. This is my hen, this is goat, this is sheep, this is cows, this is buffaloes. If I can try and group these animals, these cattle in this way, then managing each group would become very, very efficient, right? I mean, we will be able to efficiently manage them, right? From feeding right from monitoring them, right from ensuring that we take benefit of these cattle, like milk, eggs, etc., the meat. So we will have a proper plan if you have these groups segregated, right? This is your unsupervised learning. So unsupervised learning is a machine learning technique in which the models are not supervised under the training data set. That means we don't have a label in place. So models basically try and look into the complete data set and try to identify hidden patterns, which can probably will allow us to take better decisions. It will allow us to get better insights for the data. The objective here, the goal, is to ensure that we find patterns or similarity. In short, I would say similarity in the data. Right? If I have similarity, then the characteristics of the data points within each group will also be similar. Thereby, we can identify the overall characteristics of that particular group. Right? So that is the advantage that we will have if I apply this unsupervised learning technique. This is one such example. We're talking about the clustering. I couldn't find a relevant image, so I've just brought these animals into the picture. You can see I have turtles, I have fish, and I have ducks. All these are in water itself, right? All of them are in water. They basically live in water, right? Or survive in water. Now, if I can try and apply a technique, then how about using these models or techniques in order to group the data like this? Right? So when you're trying to visualize the data, you might see this kind of a natural pattern in the data. So when you try and look at these groups, which are highlighted here in the green color, let's say these are crops, assume, right? So 3 different crops. We are trying to understand what kind of characteristics this group contain. Because of the similarity or consistency, the characteristics will be similar. So it becomes easy for us to manage the clusters rather than manage the entire data set. Okay, so that is about your unsupervised learning technique. Here we have different approaches. We have hierarchical clustering, we have k-means clustering. Ultimately, these techniques basically allow us to I'll talk about those things. Let me first try and give you a generic approach, generic understanding. These clustering techniques basically are trying to quantify, measure. See, for these animals, I can probably see the images and then say that, hey, this is duck, this is fish, this is tortoise. But when you're trying to work with the data points are represented in numbers or your right categorical names, non-numeric data, right? So we basically have the data set representing the data points. Now, when I'm using a tool, right? For example, the most popular tool that we will be using is Python programming language. So if I'm using my computers and try to work with this Python programming language, then how we will use the capabilities of the computer in computing things and ensuring that we are grouping the data like this, right? So if I have to represent this concept on a 2-dimensional space, that means I'll have only 2 columns. The data will be plotted on x-axis and y-axis. And the data, when you're basically trying to plot like this, assume you have x-axis, y-axis data only. You don't have multiple columns, but only two columns. When you see this kind of x-axis, y-axis data, as I mentioned, it is a two-dimensional structure. So I will be able to visually see the data and comment about that, talk about it. So we're trying to plot this data points. And when we do that, you can see the data points are plotted like this. Each data point is x1, y1. Right? Any data point that you talk about is combination of x coordinate on x values or x-axis and y coordinates on y-axis. Right? X and y-axis or coordinates. Now, how do I find the similarities? So if you look at this concept of clustering or segmentation, clustering or segmentation, if I talk about this, then the primary objective that you will have to keep in mind when you're doing this grouping or segmentation or clustering is that each group should include similar items. Right? They should not be having dissimilar things within same group. For example, if this is my group, then I will call this as a duck group. I cannot have fish in there or turtle in that. Right? All the ducks have to be there. Only ducks have to be there. Now, when we talk about turtle, the turtle has to be in a different group altogether. So you will have similar and dissimilar groups. In similar groups, we will have similar items. In dissimilar groups, we will have dissimilar items. All right. So this is primary point that you have to remember. And these are disjoint groups. So practically, in order to achieve this on the data, we will have to use something called as distance measure. So if I have a data like this, let's say x and y. This is 2, 4, 1, 3, right? Then 0, 1. So these are some of the data points I have assumed. So if I have to represent this on x-axis, let's say this is 0, 1, 2, 3, 4, so on and so forth. On y-axis also, I'll say 1, 2, 3, 4, 5. Okay, assume. So this is basically our x-axis, y-axis. So in order to represent this data, 2, 4 is here. 2, 4. 1, 3. I have my data here. 0, 1. The data is here. Right? So on and so forth. Now, if I basically look at this, this is A, this is B, this is C. Assume A, B, C. Right? I also have another various different values. So how do I know whether A is close to B or B is close to C or is B is close to A? How do we identify that? By looking at this data, we probably may not be able to interpret a lot of things. Okay. For example, I'll say another value 3 by 3. So 3, 3 is somewhere here. So you can see a lot of data points scattered in this X and Y plane. Now I want to quantify or measure the similarity. So which two data points are closer? What is the pair which is the most closest? In order to identify that, as I mentioned, we will have to use distance technique. Right? So I'm basically talking about AB. This is the distance. AC, B and C. A and D. Similarly, I want to measure B and D, C and D. Right, so all these pairs, I'm trying to measure the distances between the pairs. Distances. How do I measure the distance? Now, if you remember your school days, in school we have something called as Pythagorean theorem that we have learned. The same distance, right? The same logic is used for measuring the distances. So if I have to talk about distance between A and B, then what is the distance on the x coordinate between these two? One is 2, the other one is 1. So that means there is 1 unit difference. Right? A to B. Similarly, what is the difference between the data points on the y coordinate? Right? One is 3, the other one is 4. So this distance has to be calculated, and we use something called as Euclidean distance measure in order to quantify the similarities here between all the pairs. And the pair which has the least distance value between them, least distance basically means they are the most closest. So we are trying to quantify the similarity here. For example, if I have to do the calculation of A and B, then I will take square root of x1 minus x2 whole square plus y1 minus y2 whole square. Okay, x1 minus x2 whole square plus y1 minus y2 whole square. So x1, it's 2, x2, it is 1. x1, x2, right? So whole square plus y1, y2, 4 minus 3 whole square. And I'll take square root of all this. So I get 1 plus 1 whole square, which is square root of 2. I can remember this as 1.414. So the distance between A and B as a pair is 1.414. The distance between A and D, let us try and do the calculation for A and D. Right, this pair. Square root of x1, x2. So I'll say 2 minus 3 whole square plus 3 minus 4, or 4 minus 3 whole square. This is also square root of 2, which gives us 1.414. Right, and I also try and look at the distances between BC, BD, right, all these things. Now, what is the distance between B and D? This one. If you look at the difference between B and D, again, x1, x2, 1 minus 3 whole square plus 3 minus 3 whole square. So what is I getting? 2 square whole square. This is 2. Right? The answer is 2. So B and D is 2. Now we keep doing these pairwise calculations. We will be able to understand that A and B and A and D, these two are basically the closest pairs. Right? So I will have to try and group these together. Okay, these values together. So maybe I will say A, B, D are one cluster. C is separately arranged, and C becomes a separate cluster. So in short, if I have to explain once again, this is my x-axis and y-axis. I'm saying there are data points like this. They are close to each other. And here you see, these are another set of data points which are close to each other. So when you're trying to measure these similarities and then try to group them together, eventually you get this kind of two clusters. Right? Very simply, you can say that, isn't it? And to quantify this, we take one record at a time and try to measure the distance between these records. So clearly, I can say the distance between these two records is very small. Right? So that is about your x-axis and y-axis. And the distance concept. Once again, remember this distance that we are talking about is called as Euclidean distance. Now you may have a question on, hey, this distance can be applied only on numeric data. What if I have non-numeric data? Right? So if the data is non-numeric, then there's a concept called as dummies, or we can say dummy variable. Okay, dummies, or we call it as dummy variable or variables. This dummy variable concept is allowing the non-numeric data to be converted to the numeric format. Okay, so that's the process, or that is the basically the logic, where we are trying to convert non-numeric data to numeric format. All right. So if I talk about the gender, for example, I'll talk about male and female. So I'll have non-numeric data like this. If I represent this, saying male as 1, female as 0, or vice versa, but by default, because alphabetically F comes first, it is given 0 in Python. M comes later, so it is 1. Okay, so that's how Python works. Alphabetically, it gives first preference to female because it comes first, and then male. So we have the new column coming into the picture, which is basically converted to a numeric representation of the same data, same column. Right? So this is basically how we convert the non-numeric data to numeric format. We'll practically also see that. Okay. So this is basically about your distance calculations. We are going to talk about something called as agglomerative clustering. This is one type of clustering techniques. Then we also have k-means type, and we have various other techniques, DB scan. Then we have optics. Then we basically talk about k-medians, k-medioids, divisive approach, chameleon approach, right? Click. A huge list of techniques are available for doing the grouping. What we are trying to understand is agglomerative clustering type, where we are trying to assume that I have how many? 9 clusters. I have 9 records, 9 data points assume. So I'll assume that we have 9 clusters. Okay. In short, we have n records, then we will assume that n clusters are there. Then we try to measure the distances pairwise. Now, once this pairwise distances are calculated, then we will merge the shortest pair. The pair of records that we are speaking about, we will merge the shortest pair. And the merge group is basically called as a cluster. So what is happening is when I have n clusters, the raw data, right? This raw data is being converted into multiple groups like this. So I'll get cluster here. That means the number of clusters, which was n originally, is coming down. It's coming down. It reduces. And we keep doing this until we have one single cluster. All right. So we keep merging, we repeat these steps. And we repeat until we get single group. Say, for example, and I'll try and explain it using another example. Let's say I have a data set. Okay. This is my data set. Assume a very large data set. Okay. There are multiple records and different columns. Okay. Data set. Let us refer to this as A, B, C, D, E, F, or G, H, whatever that right values are. So I have how many? To start with, the first step, we say that we have 6 clusters. Because we have 6 records, we are assuming that we have 6 clusters. Right? And then these 6 clusters that we are having, we are trying to measure the pairwise distances. Pairwise distances. Okay. Now, once we get the pairwise distances, we will come to know which pair is having the shortest distance. All right. So we'll come to know which pair has the shortest distance. Now, once we identify that pair, we merge. Say, for example, here I'm trying to measure the distance between A to B, A to C, A to D, A to E, A to F. Similarly, B to C, B to D, B to E, B to F. Right? This way we are trying to measure the similarities. Right. Now, once we have identified, let's assume that A, B, C, D, E, F. So I have 6 clusters. I'm writing it like this. Now, on this data, let us say we have found that BC is the most closest pair. Okay, so what we do here in the next level is we merge them. This becomes one cluster. Okay, so now how many clusters I have? I have only 5 clusters. At this level, this is the first stage. This is the second stage. At second stage, let us assume that the value D is closer to B and C pair. So at the third stage, we're saying A, B, C, D is one group. And then, we have, let me erase this, let me rewrite this. So we are basically saying B, C, D is one group. I have E and F. So now I have 4 clusters. At this level, assume that A is closest to this pair. So I'm grouping this. And these two were forming another pair. Assume the distances were similar, like what we have done, 1.414, right? So same thing happened. Distance between these two, distance between these two are similar. So here we will get 2 clusters. Ultimately, at the final stage, we will have a single cluster. This entire data becomes a single cluster. So I'll get 1 cluster. This is the process which is implemented in agglomerative clustering. The name is called as agglomerative clustering. Right. So this is based on merge. This is one approach. If I reverse this approach, then this is called as divisive clustering approach. Okay, that's a different discussion altogether. But the approach is from top to bottom. If I reverse it from bottom, if I try to divide the most longest pair or the farthest pair or record, then this is called as a divisive approach. Okay, so we have agglomerative and divisive. Now, once this is done, once we are trying to come up with this agglomerative clustering topic, or agglomerative clustering is done, where from n clusters we received one cluster, then this entire process that we're talking about here has to be represented in a pictorial format, which is called as dendrogram. Dendrogram is like a flow diagram, flow chart, where on x-axis we will have 1, 2, 3, 4, 5, 6, or we can say A, B, C, D, F, right? These numbers, A, B, C, D, E, F. Okay. On x-axis, we will have the representation of our records. On the y-axis, we will have distance. We plot distance. At the first stage, that is the shortest distance pair, was B and C. So we are trying to group these two. Right? So this becomes first cluster. Next, we saw that B, C, D were pairing together. That means D was merging with B and C. Then A was also merging with this pair. But at the same level, at this level, we have also observed that E and F were pairing together. And finally, next level, we have single cluster. This is a pictorial representation of whatever we have done here. Right? This representation is called as a dendrogram. All right. Now, once we see the dendrogram, now I want to take a decision on how many clusters do you think will make sense here? Right? So depending on my requirement, I will probably split my data here, my tree here. Assume if I cut my tree here, then I'll get branch 1, branch 2, branch 3, branch 4. That means I'm getting 4 clusters. Right? If I increase towards the top, I will get less number of branches. If I scroll down, I'll get more number of branches. All right, so this is basically how your clusters are created. Let us try and see this particular logic in practice. We are trying to understand the same logic in practice, where we will try and use something called as Google Colab. So all you have to do is launch Google Colab. It says, welcome to the collaboratory, collab.research.google.com. This is basically the website. This is how it looks like. And we will be able to create our own code by creating a new notebook. Okay, if you click on the new notebook, an empty notebook will be created. And this empty notebook that you're creating will get stored in your Google Drive, because GCP or your, I should say, Google Colab will get connected to your GCP account or Google account in short, Gmail account. So that means the code that we are developing or the data that we are basically storing temporarily will be stored in Google Drive. Okay. So when I create that, right? So this code will basically allow me to open a cell where I will be able to type the code. Text field will allow me to write some text like this. So we are trying to apply clustering technique, right, on the agricultural data. Okay, if you want to see how we can edit, just double click it and say, right, this production, then automatically this data will get highlighted. Look at that. I'm just putting it in bold. You can also try and play around with the images. We can try and give colors, right? So a lot of these play around can be done, right? Horizontal lines, horizontal rows. So all these things can be done. Right. Now, Python, if I have to work with Python, I need Python software installed in the local computer. And this Google Colab is a solution for all those people who don't have computers where your Python can be installed or interface can be installed, Python interface. So we will use cloud-based free service from Google. We call this as Google Colab, right? And we're basically trying to get the entire Python code written here and executed. Python works with functions, the concept of functions. A function is nothing but a pre-written code, right? Lines of code. These lines of code that we are speaking about are written by somebody else, not by us. And we are basically taking that pre-written code by some third party, right? It is not written by Python software, or it is not written by you. There is a third party which is writing these functionalities. Now, we as the end users are trying to reuse the code which is written by the third party. Reuse it. But in order to allow the reusability, the management of these third party functionalities is important. And because Python is an open source, community driven, the packages, we call these softwares that we are talking about, are bundled together and are called as a package or a module or a library, right? So these packages are stored in a centralized repository. We call that centralized repository as pypi.org. Okay. All right. So we talk about pypi.org, which is a centralized repository. It's like a centralized location where all the community, all the various people in the entire world try to dump their code in this centralized location. Right? We call this as a centralized repository, and the code that we are trying to dump is combined together, and each combination, right, we give a name. We call this as a package. All we are trying to do is download that into our computer and reuse it. That's all. Now, by default, there are some packages which are given default. These are packages which we regularly use from data analytics perspective. For these, you don't have to go to the centralized repository. They are readily available in our system. But there will be certain libraries which you might want to get in. Now, the packages which are by default made available are something that we just try and call out. Right? It is there in the system. We are trying to bring that into memory so that the session's memory will allow us to utilize the content for this particular session. So it is there in some location, physical location disk. This is now being brought up into the session memory. Now we use this import function to do that. Now, as I mentioned, there are certain default packages which are required. One of that is pandas. Pandas is a group of functionalities which basically hold all the codes or functions which are used for data manipulation. We are trying to add this code for data manipulation. Then we have NumPy. This is another library which is used for doing arithmetic operations. Okay, so pandas and NumPy. This is like your basic calculator. You do all the basic mathematical operations on the data which is loaded here in the pandas using pandas library. Then we have matplotlib. This is matplotlib. We basically read it as a single word, but it's actually a combination of 3 words, which says MATLAB plotting library. So this library is used for data visualizations. So if you want to visually show the data using some graphs and all that, then we can use this library. On the similar lines, we also have cbon. This is a library for data visualizations only. It complements the matplotlib very well. It has all those libraries, all the functionalities that matplotlib has, and it also has some additional visualization techniques which matplotlib may not have. A little advanced visualization techniques are there in the cbon. On those lines, we also have one more library which is very important for us to understand, which is sklearn. All of them are case sensitive. Everything is lowercase only. Remember, this is sklearn. sklearn is basically the open source third-party library which is used for machine learning implementations. That means this library contains all the functionalities, the code, which is used for implementing the machine learning techniques. And what we are going to do is apply an unsupervised learning technique. Right? This is part of your data mining, which is also called as machine learning, unsupervised learning technique. And we are going to apply clustering, right? So we will have to look at the sklearn library, which is one of the important libraries from analytics perspective. So here in Google Colab, we will be able to execute all these libraries. That means this data is going to come and sit in the sessions memory now. All these are physically present in the computer. They are going to come into memory. Next, we have to try and load the data set, right? So let me talk about the data set here. The data set that I'm talking about here is a CSV file, a comma separated values, right? Comma separated values. That means each field in the data set are separated using comma symbol. To start with, we will have to click on the folder in Google Colab. Generally, this will be looking like this. This is how your session looks like, or interface looks like. We click on the folder symbol. This will give us a temporary location where we can dump the files. This symbol, where up arrow is shown, is used to import or load the data. So all we do is click on this and we get this pop-up. The file that I want to load is agri_data, which is already there. Right? It's already there. So if you want to learn about the location, then you can see, click on this 3 dots and then say copy path. And we can mention the path here, the full address, so that the pandas library that we are using here will allow us to read the content of that data into a variable called agri_data. So this is your data. So it contains, you can see the full data set is 4920 rows and 14 columns. Right? So this is basically your data set. All right. Let's execute it again. You'll be able to see that. There are various ways to understand the data here. So we can say agri_data.info. This function will talk about the fields and the respective data types in Python. Data types in Python, right? So we basically have integer, float, object, string, object or string. We can also have Boolean, right? These are the basic data types that we see. So I have total 14 columns, right? And we have 4,920 rows. The index starts from 0. Okay. Now, out of this, we have 10 float values, 1 integer, that is total 11, and then 3 object type. This object is nothing but non-numeric. Okay, so this is basically how we can try and understand your data. These are the descriptions. So in our data set, we have district name from where the area is being, the crop is being talked about or referred to. The season, when we were recording this data, what was the season? Then we have crop. This is the type of crop that we are trying to do. Whether it is Rabi, whether it is Kharif, right? Those kind of seasons basically, and crop is the kind of field we are trying to have. So, for example, here you can see wheat is one of the crop, tur dal is one of the crop, right? So season is Kharif, Rabi, and all that. So we basically have the seasons, the crops, the district names. Then we also have the nitrogen, potassium, right? These fields, which speak about the fertilizer, or you can say the land, the quality of the land, basically in right, a hectare land. Nitrogen, phosphorus, and potassium. Then we also have pH value. Then we're talking about humidity value, minimum and maximum. And what is the overall humidity around the crop? What is the rainfall in that particular region? And what is the temperature around it? What is the total area of the crop that we are trying to look at? Right? And what is the production, overall production for that particular crop? Right? So this is these are some of the fields that we basically have the data description part. Next. If you look at this, this is the technique or tool, you can say, which will ensure that we get our data installed from the centralized repository. So this is my centralized repository. The website name is pypi.org. This is basically Python programming index. It contains multiple these packages. Each package is like a folder. So we are referring to certain folders and saying, hey, get me that folder into my computer. This can be done using a command called pip. Python installation package, you can say. Pip is like Python installation package. All we have to do is say pip install the package. We can also try and use the source code, right? Directly we can try and get the content of that particular package from the centralized repository as well. So we have pip install, and we get the data. Right, I've already installed this. When I click on this, they refer to this website. You can see here. This is basically where we try to go to. Okay, let me just try to come up with the py.org. Yeah, so this is my Python repository. So in that, we are basically trying to look at the libraries called Panda Summary. And this basically is getting installed in the system. These are sequence steps, and we are basically talking about successfully installing the libraries and their respective dependencies. Once the packages are installed, only then we will be able to use it. All right. Now, what is this package and what does these packages allow us to do is something that probably I will be explaining it tomorrow. For today, we have understood some of the basic preliminaries of Python with respect to the packages. We also talked about the qualities of the steps of hierarchical clustering or agglomerative clustering technique. And we have also understood that this technique is coming from an unsupervised data mining concepts. So hope it's giving you a little bit of better vision now. We will try and group the data that we are getting here into different clusters. And then we will try to see what kind of these clusters are formed. And after looking at the data, we will try and figure out some patterns which basically are there in our data set. So we'll continue this coding class tomorrow, and you will be actually seeing the magic happen with respect to the data. So we will connect tomorrow and try and enhance our skills with respect to the analytics in the agricultural sector. Until then, please take care of yourself. Stay safe and good evening, everyone. Thank you so much.